Hello, everyone. Good morning, good afternoon, or good evening, depending upon the time zone you are in. So today we are going to talk about modernizing your search and log analytics solution using OpenSearch Serverless. So I'm Prashant Agrawal, Senior Search Specialist Solution Architect, primarily focusing on Amazon OpenSearch Service. I have spent more than 10 years of my career in search, specifically around the Elasticsearch and now the OpenSearch. With me, I have my colleague Aruna. So Aruna, could you introduce yourself?
Hey, hi there. I'm Aruna Govindaraju. I'm part of the OpenSearch Specialist Organization, which is part of the worldwide specialist organization within Amazon. I have more than 18 years of experience. I've worked with many commercial and open source search engines, and I'm now working with the OpenSearch and customers as yourself who've got OpenSearch workload.
Thanks, Aruna. So I'm going to spend around 20 to 25 minutes to get an overview of like what OpenSearch, OpenSearch Service, and OpenSearch Serverless is in general. And then Aruna will be going deeper into the demo part. So we will start with a quick introduction to OpenSearch and OpenSearch Service, go a bit deeper onto the OpenSearch Serverless to understand the fundamentals about the OpenSearch Serverless and how it works. Then Arna will give a quick demo about the OpenSearch Serverless architecture and how do you quickly start using it within the AWS console. And then we will talk a little bit about the ingestion tools, some of the client libraries, or the changes you might have to do in your existing solution to make it adoptable for the OpenSearch serverless. And then we'll cover some of the scale in and scale out examples, like how exactly the scaling works with the serverless. And then we'll have like we will end with the pricing and like some of the next step, what you can do with respect to the migration to the OpenSearch serverless. So before getting into the serverless, let's talk a little bit about the search service within the AWS itself. Like in April 2012, we came out with the cloud search that really runs on the Solar, right? So that's what we currently sell under the cloud search, and there is no new development happening in cloud search. So we have some customers migrating off from the cloud search to the Amazon OpenSearch service. And as we're not really working on any of the new features, so because that's why what happened in 2015, so we launched the Elasticsearch service using the open source Elasticsearch. Then in 2019, AWS released an open source project called OpenDistro for Elasticsearch. So OpenDistro for Elasticsearch packaged the Elasticsearch binary with a bunch of plugins that was built to provide baseline capability and functionality to on top of the OpenDistro Elasticsearch. Then what happened in 2021 is like due to some of the licensing changes, now we forked the Elasticsearch 7.10.2 version and renamed it to the OpenSearch. So that way you can still use the open source version of the OpenSearch. And then we have a lot of partners who are actually actively contributing onto the open source project as well. That's I'm really gonna talk in my next slide as well. And when we launched the OpenSearch version in like 2021, so then in 2021 September, we launched the Amazon OpenSearch service, which is backed by the open source OpenSearch project. And now in 2023, we launched the OpenSearch serverless, which is kind of making a complete portfolio of services to be serverless within the AWS analytics. So that's the state of the world today. We have an open source OpenSearch, which is 100% community driven open source search and analytics suite derived from the Apache 2.0 license version of Elasticsearch 7.10.2. It is powered by the Lucene and really has the OpenSearch as the search and then the dashboard as the visualization interface. Then we have the plugins that were built on top of the OpenDistro are also imported into the OpenSearch, and then we are really kind of iterating and providing the additional plugins on top of the open source OpenSearch. Then at a high level, there are two use cases with OpenSearch. So one is the log analytics, where you might be doing the application monitoring, or you want to look at the latency, or maybe like you want to look at the error codes to see what is causing an issue to your application. And maybe in terms of the security, you may want to find out some sort of fraud or want to protect your application and service from DDoS kind of attack. And then when we talk about the search use case, you might want to do an e-commerce. You might have an e-commerce platform to find the product quickly, as well as you might need the personalized recommendation provided by those search engine as per your interest. So this is what a good use case with respect to the open search. So then when we talk about the OpenSearch service, so it's a fully managed service that makes it easy to deploy, operate, and scale OpenSearch cluster in AWS cloud. And then AWS take care of undifferentiated heavy lifting and enables you to run OpenSearch in the AWS cloud so that you don't really have to focus much on the kind of managing and maintaining your clusters. And it also meets and maintains the high security for authentication, authorization, encryption, and audit and security requirements. Then observability is kind of a buzzword what everyone is talking about now. So with OpenSearch service, you can systematically detect the potential threats and react to systems state through an open source solution for the observability. And last but not the least, cost for the logs and application data increases as your data grows. So with OpenSearch service, you can optimize your time and resources for the strategic work by using different storage tiering for your data. So managed service customers has a lot of flexibility in terms of configuration and management options. Like you have a choice of selecting different EC2 instances to meet the need of different workload, and that really helps to kind of balance the performance with cost having different kind of storage tiering. But you need to deploy those setup with some pre-configured capacity, including some sort of extra buffer to meet your peak demands. So, however, like customer do need some kind of internal expertise in OpenSearch to continuously tune and optimize their cluster as your workload changes. And customer also need to spend some, I would say, enough amount of time and efforts on right sizing the cluster, managing the index state management, determining the sorting and the indexing strategy, and maintaining its life cycle. So many customers come back and said, like, OpenSearch is great, we really love it, but they really don't want to, but they won't be able to focus much on their business as they might have to put some efforts on maintaining and managing the cluster. And they have to do some sort of index and sort life cycle management, right sizing the cluster, etc. So they are really looking for an endpoint solution where they can just start sending the traffic without really having to manage and worry about the backend operation, and things could scale automatically for their unpredictable workload. So this is where OpenSearch Serverless comes into the picture. So with OpenSearch Serverless, it makes it easy for you to run large scale search and analytics workload without really having to worry about your sort sizing, scaling, tuning of the cluster, index lifecycle management, etc. And it happens by automatically provisioning and scaling the underlying resources to deliver the data ingestion and query responses. And one of the key tenets while we were working on development of serverless was to keep the same APIs. And it's there like whatever API you have in the open source OpenSearch or even in the OpenSearch service, it will continue to work with the OpenSearch serverless. So this way, you do not really need to rewrite your application logic to interact with the OpenSearch serverless, as well as you don't really have to rebuild your complete ingestion data pipelines or the tools what you use to send data to the OpenSearch. And at the end, you only pay for the resources what you consume for your workload. And that really makes it a cost-effective solution to turn OpenSearch. So then what are the different building blocks within the OpenSearch serverless? So we have a concept of collection in the OpenSearch serverless. So collection is kind of a lightweight domain which comprises set of indices holding the data. And then there are basically two kind of collection. One is the time series and another one is the search. So for log analytics use case where you are generating log data from various sources, you have tons of data, you can select the time series. And for the catalog search or the maybe enterprise search or web-based search, you can choose the type of collection to be searched. So the primary difference between the search and time series collection is that such type of collection keeps all the data in the heart so that you get the same performance and the same latency what you would typically get into the managed service. Whereas time series has only latest data in heart versus rest of data is there in S3. So it's kind of automatically managing the inbuilt heart and ultra warm tiering what we have in the managed service. So that has been taken care by the serverless. So I will deep dive into like how does the basically the compute unit and other thing looks like in the serverless. So we have a capacity unit, which is also referred as your billing unit called as the OpenSearch compute unit. So this is kind of a new concept in serverless. Here, OCU or the OpenSearch Compute Unit is what you have as the nodes in your OpenSearch or OpenSearch service. So each OCU comprises of 6 GB of RAM, 1 vCPU, and 180 GB of disk. Out of those 180 GB, around 120 to 130 would be used for storing the data, and rest would be used for the other operations like doing the merges, segmentations, as well as kind of it will be used by your OS operations. And then you have an option to configure the max OCU, which help you to control the cost. And these are kind of automatically provisioned and scaled depending upon your workload. And lastly, those OCUs are shared across the collection. So if collection uses the same KMS key for the encryption, so then those OCU would also be shared. I'm going to talk in detail about like what are different security mechanism and the different encryption things, what you can configure in the OpenSearch serverless. But for now, you can just assume like, say you have 4 OCU at minimum for each collection, which could be shared across collection. And the reason why we have a minimum of 4 OCU that I'm going to talk in next slide. So basically, if we talk about like what innovation we have done in the serverless, so we have kind of created a cloud native architecture where your data is stored into the S3, and it's kind of decomposing the monolithic OpenSearch service to different microservices. So today, if you look at your data node, it will run your ingestion as well as the search. But serverless separates out your indexing component from the search component, and then Amazon S3 being the primary data storage. And this decoupled architecture let you scale your search and indexing pipe individually so that they don't really depend. Like if you're going to get a lot of traffic on the indexing, your search, and if you're not getting the search traffic, then you don't really have to scale up your search operations or like the search node. So that's how the serverless will solve the problem of like you don't really have to waste the resources on one component if it's not being used by the other. Then serverless also comes with the built-in hot and warm tier. So as I was talking in my previous slide, so basically it's kind of useful in the log analytics use case where you are kind of more focused on your recent data versus your older data could be stored into the warm tier. And then we have like the active nodes or like the active OCU and the standby OCU. So basically, you get the traffic onto your gateway. Then gateway decides whether your request is for the indexing or search. So depending upon what request is for, if it is the indexing request, it will go into the indexing pipeline. If it is the search request, it will go into the search pipeline. Then once the request comes into say indexing pipeline, coordinator gets the request, and then you have the active and standby nodes. So these are kind of active and standby OCU, which are spread across multiple AGs. So what happens, and this is the reason like why we have a minimum of 4 OCU, because we need 2 in the indexing side and 2 on the search side, so that even if your one AG goes down, in that case your workload is not impacted. You would still be able to send the indexing traffic as well as the search traffic. And then we have built the security from the ground up, and now we have the separate secure services or kind of a secure service mesh for interacting with those traffic, as well as how exactly the conversation or the I would say the movement happens across different microservices. And at the end, it also comes with the OpenSearch dashboard, which you can use to create visualization dashboard to interact with your data. So it is kind of the same dashboard what you get into the service, or if you're coming from the self-managed open source Elasticsearch, so it's the Kibana, which has been renamed into the dashboard. So let's talk in detail about the security. But anyway, like while I'm getting into the security, if you have any question, feel free to drop in the chat. We have the experts on the chat who could answer your question while I'm talking. And then we will also be having a question at the end. So now going about the security. So security has been redefined, as I mentioned, and it's kind of rewritten with respect to the OpenSearch serverless. So at first, you have an option to define the encryption key for encrypting all of your data at rest or in transit. Then you have the network policy, which could be defined to make sure like if your collection should be accessible over VPC or on public internet. And then at the end, you have the data access policy. That's where you can set up the permission either at the index level or at the collection level. And then you can use the IAM or SAML based authentication as well. So with encryption policy, you can manage many collection at scale by automatically assigning an encryption key to the newly created collection, which really matches a specific name or pattern. So say like if you are sending the data from different log sources, for example, you are sending HTTPD log, Nginx log, container logs, you can have a pattern, say HTTPD hyphen star and then container hyphen star or the Nginx hyphen star. So you can actually send these data to even different collection by using the same KMS key, and then all the OCU within those collection would be shared. Then you once you define those key as a dev star, so that way you don't really have to worry about I would say creating multiple keys for the similar kind of collection if you're going to use. Or maybe you can have just one policy like say wildcard collection encryption policy that will be applied to all the collection. Then they would be shared if they are using the same encryption key. And that is the reason like whenever you create a new collection with a unique KMS key, it will require its own 4 OCU. So, but if you use the AWS own key, then all collection will share the same key, which means all OCUs using the AWS owned key would be shared at the account/region level. So what does it mean? It means like if I have 10 collections and if I'm creating it with say AWS owned key, so then it will bootstrap your OCUs with 4. And even for those 10 collection, it's not like 10 into 440 OCU, rather it will be using only 4 OCU. And then those OCU would be shared. And if your workload increases across any of those collections, and if it demands more compute power or the resources, then it will be automatically scaled up. Then talking about the network settings, so with the OpenSearch serverless, you can determine whether your collection should be accessible over internet from public networks or it should be accessible on the VPC. Then the thing is, encryption policy, once you define, it could not be changed after your collection has been created. But with the network policy, you can change it at any time. Like you can switch from like VPC based collection to the public collection or public to VPC at any time. And then like you can have like multiple network policy to single collection, whereas in case of the encryption policy, you will have only one key, one collection per key. And then the reason for that is because the thing is with the network policy, you have an option to define the VPC endpoint or the public access. And from the customer, what we heard is like they want typically their programmatic access or the OpenSearch endpoint access behind the VPC, but they want their OpenSearch dashboard to be accessible on public. So what today customer do is like they create the complete OpenSearch service in the VPC, and they have to kind of launch a proxy server like say Nginx proxy, which will be behind your instant VPC, and then that will be used for accessing the dashboard. But with the serverless, you can define the separate rule for the OpenSearch endpoint and the dashboard, and that way you can have your OpenSearch endpoint or like all the programmatic access behind the VPC, and your dashboard access could be there on the public access. But there can be a situation like where your network policy might overlap because you can define multiple policy at the collection in terms of the network. So when this happens, a rule that specifies the public access, it will override all the rule that specify the VPC access for any collection then in across the collection when they kind of share the different network policies. So then next is the data access policy. So you can use the data access policy to define the rule for setting up the permission at the index level granularity. And those permission can be set up either at index level, such as like read, write, create, delete. So those would be index level permission. And then if you want to do some sort of index management permission, such as the managing the alias, creating the template, so that also could be controlled using the data access policy. Then you can either use the AWS console to log into dashboard using your IAM credentials. So we have an option of pre-signed URL so that from the AWS console, you can directly sign into the OpenSearch dashboard if you have the proper role defined. But if you are using any sort of identity provider or the SSO integration, then you can also integrate your single sign-on using the OpenSearch serverless. And then basically you can have a policy at the wildcard policy as well, which could be defined at collection/star means this particular data access policy would be applicable for all the collection. And then at the index level, you can define like a wildcard, say index/star/star. So the first star is basically the index pattern, and the second one is like what permission you want to give. So say if I only want to give my log index the read permission, then the policy would be something like index slash log slash read only. So that kind of policy you can define using the data access policy. And with this also, like you can have multiple policy to single collection. And if you happen to have the multiple policy or multiple matching rules, then all operation would be club dash or operation. So say if you have one rule which is explicitly give the access to specific index and specific permission, say read only, but other group is also assigned to the same collection and it gives the wildcard permission for read and write. So in that case, the user will have the read write both permission because all the policies would be clubbed and applied at the index level. So with that, I'm gonna hand it over to Aruna. So this where she would be talking about this demo setup followed by a demo.
Yeah, thank you, Prashant. That was fast and a lot of information there. So today we will be looking at this demo architecture that we have set up for you. This took about 30 to 40 minutes for the overall setup. So for the sake of the presentation, we have some pre-built that we will go over things and also have a deep dive into how the serverless collections are set. So today with this demo, we have the OpenSearch serverless collection setup. And with that, what we will be doing, we will be creating a fire hose, a Kinesis fire hose with a delivery stream pointing to the OpenSearch serverless collection. So anything that is fed to the delivery stream will be ingested into OpenSearch serverless. So today in our demo, we will be ingesting the VPC flow logs from your existing VPC. And that flow logs will be routed to your Kinesis fire hose delivery stream, and the VPC flow logs have a specific format, so we would require some transformation done, and we will leverage Lambda and write a custom code to transform the VPC flow logs into a format that the serverless collections can absorb. So it would be a simple name value format, and that will be ingested into OpenSearch serverless collection. We will also look into setting up the S3 bucket in case of any failures, capture any errors that we would come as part of the from the fire hose as well. With that, let me quickly share my screen. Go to the OpenSearch service and let's look at how we would create a collection. So I have a pre-built collection, but we will also look at how we would create one. Let's create today's demo collection. And as you can see, at the time of collection creation, we would actually choose between whether it's a time series or search. This will allow the service to actually optimize your collection for that specific workload. In time series, all the recent data, all the recent index is actually placed on the hot node, while all the other data is moved on to the ultra warm, unlike in search where everything is placed on the hot node because all the objects are mutable and there is a regular update which goes on. And like Prashant mentioned, there is an option where we can specify the encryption key. You can either use an AWS owned key, or you can also choose to have a different key which is part of your organization. That's with the encryption. And again, network access setting is something that we also spoke about, wherein I can deploy my collection within as a public collection or within a specific VPC. Here, as you can see, the resource types are of two types. One is enable access to OpenSearch endpoint, and the other one is dashboard. With the OpenSearch service, if you remember, we can really create we can deploy the entire cluster into either a VPC or define the entire cluster as a public. But in most of your cases, we do see that OpenSearch is mostly is within a VPC, while the dashboard is public, and the access is really controlled by user group information coming from other identity providers. So with that, let's create the VPC. So I'm gonna go and choose the VPC. So this is a VPC endpoint. This endpoint you can quickly create by pointing to the VPC that you would like to deploy your collection within, and then choosing the appropriate subnet. Like say if I choose this, I will be listed with all the subnets that I have within this particular VPC. Let's quickly choose to see how it's done. And then once you have chosen the subnets, select the default security group and confirm. And this actually, and the name, of course. I already have this VPC endpoint, so I'm not going to create. I'm going to cancel and use the existing one. And then let's click on next and go to the next. This is the place where you would configure the data access. So there are two principles under which is available for you to create access to your specific index. So one is using the IAM user and roles. The other one is using a SAML user groups. So so here, when I choose, I can choose what IAM role that I want to choose against. I do have a Kinesis Firehose demo role which I've created here. I'm going to do a quick save, and I can select what permissions this particular role needs to have on my index and at the template and permission level. So one more option, I can also create another role where let's go over the other option which is available, which is basically the SAML user group, wherein you can create your SAML endpoint by creating a SAML provider. I have created a SAML endpoint by integrating with the Okta external identity provider, and there is a handshake done by creating an Okta application will give me the external IDP metadata, and that is configured as part of my SAML endpoint. And once that is done, let's go back. So once that is done, your SAML endpoint that you've created will appear as part of your listing. And that is also something that you can provide access to. Now, I'm going to just quickly skip that. I will show you how that can be done. I'm going to skip that, and we are going to continue to use the IAM role. And let's go next. Okay, that was
Mhm.
okay. Now on to the data access policy. Let's give a policy name. And let's do a click. And then when this is the page where it's a summary of all the configurations that you've created a demo collection for today, and then you've moved on and you've enabled the encryption with an AWS owned key, and you've deployed your collection within a VPC for both the endpoints. We can see how we would enable the public endpoint on the dashboard later during our presentation, and let's submit. And this would take about a minute or two for the cluster to get ready, for the collection to get ready. In the meantime, let's go in and look at Kinesis. So the second step in our architecture is to create a Kinesis delivery stream. I've already pre-created a delivery stream because the delivery stream takes about 15 to 20 minutes to create, but let's look into what are the options here. So there are two ways to, you can either have a Kinesis data stream be fed in, be the source for your current data stream that you're creating, or you can have any external logs coming in from, say, VPC flow logs or any other logs or CloudWatch logs, which can directly be configured to put on your stream. And here you choose the destination as serverless. So that's new. With the release of serverless, we have now extended Kinesis stream to also support the OpenSearch serverless. When you choose that, you have given a delivery stream name. And for the transformation, so we did speak about having the architecture feed the VPC flow logs. So we will see the structure of the flow logs, but for the flow logs to open, we would want the flow logs to be converted into a name value pair JSON that the OpenSearch serverless can understand. So let's look at the Lambda which is available. So this is the Lambda which is created, and let's quickly look at the review the Lambda code. This is a very simple Lambda code. It's available on the external GitHub. We can share you that link to that. And as you can see, this code, all it does is take the VPC flow log one line at a time, convert the flow log, split the flow log by space. So each of the name value pair is splitted, is identified, and it's split by the space, which is one of the separator. And we create a name value pair array, which is again put back into the output stream, which goes back to the Kinesis Firehose. So here, let's choose the Lambda, and so that we can capture that output stream. Let's leave the buffer size and the time interval as is. And as you can see here, the destination settings. So now that you've created the transform records, and here the destination settings, it should of course go to our cluster. Let's see if it's created. It's still in the process of getting created. So let's choose the, let's see if it's getting, if the creation is done. Yeah, there you go. It's active. I'm going to choose the April 13 demo. Now I have the collection created. Now I want to create a name to the index. This will be the index which will be created for this with this particular feed. And then, as you saw, our collection is deployed within a specific VPC. So we would have to choose the same VPC in which our collection, OpenSearch serverless collection, also is deployed, so that the Kinesis Firehose is also on the same VPC. So we don't have to get into looking at VPC peering and other things like that. So I'm going to choose the subnets which is of my interest, and also choose the same security group. And if you remember correctly, we did have a bucket, configured bucket to make sure all the errors goes into a specific bucket. I'm just going to use the pre-existing bucket. You can alternatively also create bucket on the fly and have that bucket pointing to this particular Kinesis data stream. Now, in the advanced section, as I scroll down, you would see a place where the Kinesis would create the default IAM role. If you remember, the IAM role permission that I have given on the OpenSearch service cluster is the one of the Kinesis role that I have created, this one. And that is what I would give the Kinesis also access to. So Kinesis will go in as the same IAM role to create that specific index. Now let's click on the create delivery stream, and this would create the delivery stream as per the configuration that you have chosen. This delivery stream would take about 15 to 20 minutes to create. So let me open the other pre-existing one and quickly go over the configuration. It is exactly same as what stream that we just created, with the VPC name and the set of subnets into which it belongs to, and of course the security groups. And if I scroll down, the service access would be, so to access the service from the Kinesis stream, I need this particular IAM access to the data stream as well. So with that, we are done with the second part of the architecture. Now let's move on to the VPC flow logs. And let's look at how we create the flow logs. So I have an existing VPC in which I'm just going to enable the flow logs. So I have already enabled it, but let's go over it once again. So I can give a specific name, and as you can see, I can create flow logs to capture either a specific accept, reject, or all traffic to my VPC. And the aggregation interval is basically the speed in which these four flow logs should be generated and passed over to its target. The target can be any one of the four. As you know, we have a ready-made Kinesis Firehose, which is set up at the account level to feed these flow logs. And when I choose and whatever Kinesis data stream that you just created, again, it would take about 15 minutes. So I have a pre-built one. So I'm just going to choose that. And as I scroll down, you can see the format, the default format in which VPC logs comes in. And this is the format that we take, and we would pass this format using that Lambda code into a name value pair that OpenSearch service can understand. OpenSearch serverless can understand. And with that, let's go ahead and create on the flow logs. There is an existing flow log. Okay, let's use that. So this is the flow log that I have created so far. Now let's move on to back to the OpenSearch service. And I'm going to click on the collection. So we have this OpenSearch service active. We still haven't created the flow logs there to point to the new Kinesis server. So we're going to wait for the Kinesis to move on while I showcase what we have done here. So let's go to the, sorry about that. Okay, I'm going to just go into the serverless. And as you can see, click on the demo serverless logs. It's pre-logged because it's using IAM by default. Like Prashant earlier mentioned, there are two principles that can be used. The IAM is a pre-signed URL, which allows me to, since I'm already logged into my AWS account, clicking on the dashboard is going to directly take me to my dashboard UI. And I'm able to sign into the dashboard without having to do anything because my user credentials are given access to the particular collection. Now I can log out, and you might have different SAML providers. So you might have more than one identity provider on your organization to which you want to give access to. So I have created a SAML provider to an external identity provider, which is Okta, and all the user and group information comes from Okta. So when I've had to use SAML and login, and now again I'm given with oops, back to sign in page. So I can actually choose one of the users. These users are users coming in from Okta. Now I'm gonna sign in using the user one to which I've given access on the SAML configuration. So now I'm inside the dashboard. Now let's look at the options that you have on your left nav. So with OpenSearch service, you would see a lot of other options which are related to plugin, but serverless, there are more restricted number of plugins which are available. And but dashboards and discover and the dashboards are some of the functionalities that we have seen earlier with the service, which is still available for us. So I have created, let me go to the dashboard. I have created a single VPC flow log metrics using the stack management. Let's look at my stack management. And I have created for a pattern of VPC flow log. So this is the index that I've created inside inside my collection, and that's the index which is collecting all the VPC flow logs. So when I were to go and log into my dashboard and click on my dashboards, these are some of the pre-built dashboards which gets refreshed based upon whatever data that you have on your, let's do 24 hours. There you go. So I had, these are some of the log information, VPC log information that is being collected, and they are all pre-built dashboards which are available, wherein you can look at the VPC flow logs and see how many accepts, how many rejects, and total packets which is come in, and the size of the package, and what are the IP addresses that are being captured, and what is the size of these packets coming from these IP addresses. And this is a heat map which shows what is the source and what is the destination IP that is often talking to each other. So as you can see, some of the color codings that you give here also shows about the quantifiable number between the interaction between the source and the destination IP. With that, we come to the end of the demo. Any questions or anything that we want to see at this point in time? Or else, Prashant, could you share
Yep.
the slide? Yes, there you go. Um, so there are one thing I wanted to talk about in terms of Kinesis. It's easy to use, and that's one of the reasons why we wanted to also use that as part of the demo. Like I said, it took us about 30 to 40 minutes to set up the overall the architecture, including the time it took to actually spin off the Kinesis data stream. Now, for the ingestion tool, most of you might be already using OpenSearch service. So the best part of the architecture of serverless is that we can reuse whatever ingestion pattern that you're used to currently, and just repoint that to the OpenSearch service. As far as the repointing goes, you just would have to change the endpoints, and you can point your current existing code or your ingestion pattern onto the OpenSearch service serverless. So some of the tools that we are very familiar with is first, we have a bunch of language client, which goes from Python, Java, Go, and you can build your own application to do the bulk ingest. And then, of course, most of you will be familiar with the AWS. When as far as AWS integrations are concerned, we usually go with we recommend that you go with Kinesis data stream, Firehose, or the Lambda service to do a bulk ingest. And of course, we are also familiar with the open source option. There's a bunch of tools which are available, which is open source, which can be leveraged, configured to do ingestion directly to OpenSearch serverless as well. So that includes the Logstash, FluentBit, the FluentD, and the Kafka Connect. Over to you, Prashant.
Thanks, Aruna. So, like you saw how easy it was to kind of configure the OpenSearch serverless and then send your VPC flow logs using the Kinesis data firehose. So now I'm gonna go a little bit deeper onto the scaling, like how exactly the scaling happens with the OpenSearch serverless. So to start with, you have two OSU as default when a collection is created on the indexing side, and then OpenSearch serverless will scale out based on some of the metrics. So those metrics involves like your sort count, your disk utilization, and the CPU. So whenever your sort count goes beyond 75 number of 70 no, 75 sorts per OCU, then your scale out will happen, and these limits are kind of per OCU. Or if your disk utilization goes beyond 60 percentage, or if your CPU utilization goes beyond 50 percentage. And what the service does, like it kinds of keep monitoring it will continue monitor all the metrics across all of your OCUs. And if any breaches happens across these metrics, it will scale out. Then how about the search side? So, and how exactly the scaling happens? So for the scaling also, it's the same similar matrix, but in case of a scale out, we capture all the matrix. It's kind of an OR condition, whereas for the scaling, it would be AND condition. So whenever you have like less than 50 sort per OCU, or your disk utilization goes less than 40 percentage, or if your CPU goes below 25 percentage, that's when your scaling will trigger. So that is basically how your scale out and scaling happens, and what all metrics we really capture for performing those operations. And search auto scaling is similar to the indexing auto scaling, so there is no difference on that one. But in terms of like in search collection, you will have like all of your data into the hot. So that is the only difference. And in case of matrix, it's the same matrix. So another thing to note over here is like you will keep on scaling out the resources as your data grows in case of search, because you might not be deleting any data over there. Because typically, if it is your enterprise search solution or the web catalog search, you might not be deleting the data. So you have to make sure basically you need to understand like you might be scaling up all the time with respect to your indexing side as well as the search side, because you have to keep all the data in the hot. But when we talk about the ultra warm architecture, so in this case, it's kind of inbuilt hot and warm architecture, and the scale operation is intelligently handled. So your latest data is into the hot OSU, whereas your old data is stored into the S3, and a portion of metadata is stored in the hot OSU as well for the data stored into the warm. So current, and in that way, like you might have say like you want to store 2 days of data into the warm, or like 5 days of data into the warm. So that way your data would be stored in, like the portion of metadata would be into the hot OCUs, and the old data will still be there into the S3. So overall, if when we talk about the pricing, so if you look at the OpenSearch service pricing, it is going to be based on your configured instances, and then you have to have some sort of additional overhead for high availability, ultra warm node cost for leveraging the hot and ultra warm storage steering, and then you also add some buffer at the end for like say your total disk utilization or the performance what you want to meet with respect to your CPU and memory. But whereas in case of the OpenSearch serverless, customers are really charged by the indexing and search issue, and along with you also have to pay the storage cost, which is kind of near about S3 storage pricing. And if you look at the chart, so serverless pricing is not going to be constant or flat, similar to your service pricing. And in the serverless, you will have the peaks and valleys depending upon your workload. Whereas in managed service, you will continuously see the flat cost depending upon whether you are utilizing it or not. So then couple of things with respect to how exactly you can migrate your data into the OpenSearch serverless. So here are some of the tips and tricks for that one. So I have a blog post which you can use to learn more about migrating your existing data from the self-managed open source Elasticsearch or OpenSearch, or even if you're using the OpenSearch service to the serverless. So basically, Logstash has an input plugin for the Elasticsearch, open source Elasticsearch, as well as the open source OpenSearch and the managed service. And then you can use the output plugin for the OpenSearch to write the data into the serverless. So, and the next thing is like you should really reduce the blast radius by letting the serverless manage the indexes and sorts. So, as one of the things, as I mentioned earlier, like serverless takes care of kind of managing and maintaining your index and the sorts, and then defining the lifecycle policy and etc. So that's what you should not basically kind of create your own indices on a daily basis in case of log analytics, so that you don't really have to worry about doing any sort of rollover, and serverless will automatically roll over depending upon the size and the pre-configured limit it has. And it will basically reduce the blast radius as well when it's kind of managing by its own. And then you have to consider like when you're creating a search type of collection, your all data will be stored in the hot. And when you create the time series collection, your latest active data could be on the hot, and the rest of the data would be into the warm, and warm as in like it will be stored into the S3. So a quick recap. So basically, if you want to get like, okay, so how do I choose like I should go with the managed cluster or the serverless? So if you want to get full control on sizing, defining the capacity, choosing the instance type, storage like EBS or the instance storage, then you can go with the OpenSearch service. And also like in case of service, you would be having the flexibility to tune your index and sort management along with any customization you might have to do from setting perspectives, such as the routing, changing the cluster setting, etc. And on the other hand, if you don't really want to manage any of those things with respect to sizing and scaling of your OpenSearch clusters, and also you don't really want to worry about the index rotation, index life cycle, etc., then you can let the serverless handle the automated scaling of your cluster, automated and managing all the index and sort life cycle management. And also it will come with a built-in hot and warm tier so that you don't really have to worry about that. So what are the next steps? So here are some of the resources which you can go through to know more about the serverless, which consist of the serverless documentation, some of the blog post what we have written. So we have a blog post for the exact same demo what Aruna gave, where you can create the end-to-end log analytics solution using the OpenSearch serverless Kinesis data firehose. And then in terms of the source, your data could be coming from say S3, or it could be your VPC flow logs, or it could be coming using the Kinesis agent, which could be deployed on your on-prem instances as well. And then at the last, we have a getting started workshop. So this workshop basically gets you hands-on experience for running the OpenSearch serverless for both of the two use case or the scenario. And then in case of the log analytics, it has the example of setting up the logs test, how to use the Python client to send the data, as well as how to send the data using the Kinesis data firehose. And then the second case, in case of the search, it will walk you through like how you can create the index using the dev tools, and then how you can perform the search on those data sets.